Hello my dears. Actually it's night here due to some personal assignments. I couldn't record my video on daytime, but actually I can postpone this video to tomorrow also, but my mind it is not good actually. Suppose I postpone this video to tomorrow, definitely some of you may expect my video on tomorrow morning itself, so I don't want to make you sad by seeing no videos here for today morning. That's why, so it's almost 10 p.m. now, so I'm recording this video anyway. So there may be some issues with the light, but in board I think it's very clear, but maybe my face and it may not be that much clear due to the lighting issue. So I hope you understand, and let's come to the point. Okay. So my dears, in the last class we discussed about some important functions, right? Functions, because we don't actually the main the importance of studying different types of signals or functions in our electrical engineering is that we can't predict the type of input suddenly appear across the circuit, right? Suddenly appear across the circuit. So we have to predict our output. Suppose these type of input are given to the circuit. That is the reason why we have to learn about different types of function like impulse function, unity step function, etc. Okay. So today we are going to deal with a new topic called transients. So what is mean by transients or transient condition? Let's see that first. It is slightly difficult with respect to the other sessions of electrical engineering. Compared to other session, it's slightly difficult. So it needs some patience in order to get the clear idea. So please make your mind prepare for that, okay? Because transients are very difficult subject actually, very difficult session, not subject actually, very difficult session. I will deliver my maximum, okay, in easy manner also, in order to get a clear idea, okay? And questions are also very rare regarding this transients session. So anyway, we will learn and we will see how can be done, okay, how can be done. So what is mean by transients? Transients are nothing but a sudden change in the system. A sudden change in the system parameter is termed as the transients or transient condition. And the reason for that sudden change is called the transients. Okay. So transients are nothing, transient condition is nothing but a sudden change in the parameter of a network or system. Parameter in the sense current, voltage, resistor, inductor, capacitor, etc. And voltage across the inductor, voltage across the capacitor, etc. That are termed as the parameter here. So a sudden change in the parameter and which exists for very short duration of time is called the transient condition. And the cause of such conditions is termed as are termed as the transients. For example, suppose simply you switch on a tube light in your home. There is sudden introduction or there is a sudden inclusion of an inductive load here, right? Tube light is considered to be winding is there, so it is likely an inductor like. So if you suddenly switch on an inductor in your home, you may feel that there may be some flickering on the TV, right? Flickering on the TV, you might have noticed that flickering on the TV. Before the tube get full brightness, when it blinks, there may be flickering on the TV. That is a type of transient. That is a type of transient. That means a sudden disturbance or a change in the parameter in the system due to some other condition is termed as the transients. There are two types of transients are there. First one is AC transients and Second one is DC transients. DC transients. That means there are two type of transients, AC transients and DC transients. AC transients means nothing but the source is an AC, like our tube light case, no, in our home. That is a type of AC transients. DC transients means the supply will be simply DC. So AC transient means supply will be AC, supply is AC, and here the supply is what? DC. That is the only difference. And can you tell me another example of transients? Let's see that. Suppose you suddenly switch on a single switch. Our switch, no, DPST switch. Our DPST switch, no. Our simple DPST switch, no. If you suddenly switch it on to your circuit, then also there is a production of transients. That means a sudden disturbance in the system happens there. That is also termed as a transient. That is also termed as a transient condition. And what is the cause of producing such a transients is the presence of L and C. If the circuit contains inductor or capacitance, or the combination of inductor and capacitance along with the resistor, along with the resistance, there is, if you disturb your circuit, there is a chance of producing transients. There is a chance of producing transients. If the circuit is pure R or pure resistive in nature, then there will not be any transients, because L and C are the things, or are the elements in an electrical as well as electronics engineering, which change its nature with respect to frequency. Transients are nothing but changing the original frequency or introducing a different wave into the system, and that wave will be some multiplication or some multiples of the fundamental AC wave that we apply. That is the reason why it affects the inductor as well as the capacitor. Because only this inductor and capacitor, you know, XL is equal to L omega and X is equal to 1 by C omega, depends on frequency. If there is a transients, means it differ the frequency of the fundamental waveform. Try to differ the frequency of the fundamental waveform. That's why there is a problem if there is L and C in a circuit. That is the reason. And generally we represent a representation of L and C. A representation of L and C. A representation of L and C. Generally our inductor, this is our inductor, is represented like an inductor in series with a current source, that is represented by IL of 0 minus. And let's learn what is the 0 minus, 0 plus and all. Let's learn that. There are three instants at which we are analyzing the transient operation of a circuit. First is nothing but t equal to 0. T equal to 0 is a point at which transient occurs. Transients occurs. So T equal to 0 is the point at which transient occurs. For example, if you switch on a tube light in your home, the switch on point is considered to be, the time at which you switch on the light is considered to be T is equal to 0. Any time interval prior to that is considered to be T is equal to 0 minus. Any time interval prior to that is T is equal to 0 minus is considered to be what? Steady state condition. What is that? Steady state condition. Because before we switch on our tube light in our home, the system was stable, no? The system was stable. The system wasn't subjected to any of the disturbance from the surrounding or internally or externally. That is why it is called the steady state condition. And another term, instant is called 0 plus. 0 plus is the time at which soon after we introduce the transients is called the t is equal to 0 plus. That means the maximum transients occurring point, maximum transients or disturbance occurs. So at this t is equal to 0 plus, maximum transients occur in a system. Maximum transients occur in a system. And another time is called t is equal to infinity. This is also called stable time or stable condition. Stable condition. So these terms you should take care. These terms you should take care. That means this time terms, right? 0, 0 minus. 0 is the time at which we introducing the transients. 0 minus is prior to transition condition. 0 plus is soon after the transition condition. That time is the maximum transients occurring condition. And after long time, t is equal to infinity means after long time the system itself adjusts to the disturbance and make it stable after some time. That means the system will attain stability after some time. That is called a t is equal to infinity or stable condition. T equal to infinity or stable condition. Is it clear? So that's all about the the time of operation. And let's representation of L and C. Let's see, come back to our point. Normally L is considered to be an inductor in series with a current source. Current source IL of 0 minus is what? 0 minus means steady state condition. That means if you are analyzing an inductor, definitely that inductor will carry some current before, right? That current is very, very important for the analysis of transients, because unlike resistor, inductor is something which is what opposes the changing time, changing the current through it, right? So definitely the initial current has the very, very strong impact of the inductor properties. That is why this IL of 0 minus is always representing along with an inductor. This is an ideal, this is a representation of an inductor, right? And a representation of capacitor is nothing but this is our normal capacitor. But when we are dealing with the transients or when we are doing transient analysis, the capacitor is considered to be this is this is actually in parallel. Okay, this is actually in parallel, but I'm really sorry. L of 0 minus, because current source is always represented in parallel, right? That's why. And here it is voltage, capacitor. This is VC of 0 minus. This is nothing but the voltage source in series with the capacitor. So this is the representation of inductor and capacitor during transient analysis. Because these initial values, it has some importance. It will be more and more clear when you are dealing with some problems. Okay. That means nothing but if you take a capacitor or if you consider a capacitor, definitely its history of voltage should be considered, right? It has certain voltage, right? So that voltage also you should consider. And same manner, if you are considering an inductor, then also you have to consider the initial value of current in it. That current is termed as IL of 0 minus. The initial value of voltage is termed as VC of 0 minus. So this is the representation of inductor as well as capacitor in transient analysis, only in transient analysis. Okay. So that's all about the important terms. And yes, we have two types of circuit. One is source free circuit and second is source full circuit. One is source free circuit and next one is source full circuit. So let's see one by one. See, say a circuit here. Some V of t here, some V of t here. Okay, so this is a simple circuit. This is a simple circuit. So what is the meaning of the circuit is that before t is equal to 0, the switch was in this position. Switch was in this position. That means the RL is connected to source directly. But when t is equal to 0, that is the point of interest, our point of interest or our cup of tea, right? So at that point, at a t is equal to 0 point, what happens? The switch is suddenly shifted from this A to B. That means now this is connected to here. So this is the circuit now. This is the circuit now. That means this is excluded from the circuit now, right? This is excluded from the circuit now. Now this is called the source free circuit. Now this is called the source free circuit. That means our area of interest is nothing but at the point at which t is equal to 0 and after that, right? In order to get the transient analysis. So if the circuit is operating without a source at t is equal to 0, then it is called a source free. If the circuit is operating with the source at t is equal to 0, then it is called a source full circuit. For example, suppose here is some voltage source. You imagine here also some voltage. So let be V2 of t, let be V1 of t. If you switch the circuit from point A to point B, then this is now connected to a source. Initially we don't bother about, because at t is equal to 0 only we start, or there is a transient production, right? So at that point only we have to consider, right? So whenever you shift your switch from A to B, what happened? Now also there is an inclusion of source, that is termed as the source full circuit. So that is the difference between source free and source full circuit. Okay. And we have to know some basic equation for the source free as well as source full circuit, then only we can solve some problems. Okay, let's see what it is. Let's see what it is. Let's see what it is. You have to continuously revise this session, then only things will be clear to you. Okay, because this is somewhat difficult session. Okay, first we have to see source free RL circuit. Source free RL circuit. This is nothing but this, the same figure. The same figure that I draw before. The same figure that I draw before, right? This is and for source free RL circuit, this is source free RL circuit, we have an equation for, if there is RL means definitely we have to consider for currents, because inductor is nothing but it opposes the rate of change of current in it, right? So definitely our area of concern is current. So for source free RL circuit, there is an equation for the current at t, any time t. IL of t is nothing but IL of 0 minus e raised to minus t by tau, e raised to minus t by tau, where tau is nothing but time constant and which is nothing but L by R. L by R, which is nothing but L by R. So this equation you should take care. This equation you should by heart. It is actually obtained from a very long derivation, but derivation we don't need, right? So you have to keep an eye on this equation only. IL of t is equal to IL of 0 minus into e raised to minus t by tau. And if the circuit is source full RL circuit, right? If the circuit is source full RL circuit, then we have another equation for the current IL of t, which is nothing but IL of 0 minus IL of infinity into e raised to minus t by tau plus IL of infinity. Very, very important relation. If the circuit contains, if the circuit is sourceful RL circuit, then IL of t will be equal to IL of 0, that is nothing but the initial current, that is IL of 0 minus. Prior to the transient occurring, IL of infinity means stable condition, right? Stable condition of current, stable current, right? And e raised to minus t by 2 plus IL of infinity. This is a very important relation. Similarly, if you consider for source free RC circuit, what is that beta? Source free, this is 1 and this is 2, this is 3. Source free RC circuit. Source free RC circuit is nothing but the same circuit, but this is C instead of that R, I mean L. This is called the source free RC circuit. Here also there is no source when the switch is shifted from A to B, right? That's why it is called a source free RC circuit. Whenever we are dealing with a capacitor, we have to take care of the voltage, right? Voltage is important in a capacitor, current is the important thing in an inductor, right? Simple manner. So if it is source free, then Vc of t is nothing but Vc of 0 minus e raised to minus t by Rc. This is the equation. Vc of t is nothing but Vc of 0 minus e raised to minus t by Rc, where Vc of 0 is nothing but initial voltage in a capacitor. Like IL of 0 is nothing but initial current in the inductor, right? Similar manner, Vc of t is nothing but Vc of 0 e raised to minus t by Rc. If the circuit is sourceful, if the circuit is sourceful RC circuit, that means there also a source now, then there will be an equation of Vc of t will be equal to similar manner Vc of 0 minus Vc of infinity into e raised to minus t by Rc plus Vc of infinity. This is the equation for sourceful RC circuit. These 4 equation beta you have to by heart. These 4 equation you have to by heart. This is actually obtained from very, very long derivations, but we don't need that derivation. We just need the formulas and we have to apply that in but questions. That's our aim, right? So that's about source free and source free RL circuit. And let's do some problems and we will learn more. Okay. Let's do some problem and we will learn more. Through problem only we can learn something. Okay, that is my aim. And before we look into a problem, if so many theory I have taken, then it won't digest. So my style of teaching is that through problem learn the concept. Okay, let's do a problem. Okay, write a question. The question is find Vc of t, IC of t comma VA given that such that initial voltage across C is 6 volt. Okay, so that's our question. That's our question. So first thing you have to note here is that whether our circuit is source free or source full. That is the first thing you have to keep in your mind. So in this circuit itself gives an idea of it is not a source circuit, right? It doesn't contain a source. So it is a source free RC circuit, right? It's a source free RC circuit. So we have to say the VC of t, right? What is the equation for VC of t? VC of t is nothing but for source free RC circuit is nothing but VC of 0 minus e raised to minus t by RC bus. That is the equation. That is the equation, right? So what is VC of 0 minus? It is the initial voltage across the capacitor. It is given, right? 6 volt. That means VC of 0 minus is nothing but 6 volt beta. VC of 0 minus is nothing but 6 volt. And let's look at this equation R and C. What is that? It is a time constant, right? R and C is a time constant. What is R here? R equivalent here. What is R equivalent here? R equivalent is calculated with respect to the capacitor. By looking from the side of a capacitor, what is the effective value of a resistance it feels is considered to be the R. So by looking from the side of a capacitor, this feels an effective resistance of 60 ohm in parallel with the 60 ohm, right? So R equivalent is nothing but 16 parallel to 16, it is nothing but 8 ohm. And C is nothing but beta, C is nothing but 1 farad, right? 1 farad. In this question, it's given actually, yes, it's given. I forgot to write, it is 1 farad. 1 farad. So what is C? 1 farad. So RC is nothing but beta, RC is nothing but 8. RC is nothing but 8. So what will be the equation of VC of t? VC of 0 is nothing but 6 e raised to minus t by 8. Bus. Minus t by 8. Where RC is called the time constant of RC circuit. Bus. Time constant of RC circuit. Okay. So that is the equation for VC of t. That is the equation for VC of t. Is it over? Our question over? No. We have to find IC of t also, right? IC of t is nothing but beta C into d by dt of VC of t. Am I right? I in a capacitor is nothing but I is equal to C into dV by dt. We learned that, right? So IC of t is nothing but a C into d by dt of VC of t. But here C is equal to 1. So 1 into d by dt of what is VC of t here? 6 e raised to minus t by 8. Correct? Correct? So it will be equal to, what is that? 6 is constant, e raised to minus t by 8 into minus 1 by 8, right? So it will become minus 6 by 8 into e raised to minus t by 8, or it will become minus 3 by 4 e raised to minus t by 8. That is the value of what? That is the value of IC of t. That is the value of IC of t. So now you have IC of t also. Now you have IC of t also. Is it over? No. We have to find VA also, right? We have to find VA also. VA. VA is nothing but beta. The voltage across this 4 ohm, right? The voltage across this 4 ohm. All over this voltage, I mean from here to here, it is nothing but VC of t, right? So what is the voltage across this 4 ohm? If here it is VC of t, apply voltage division rule here. So VA is nothing but VC of t into 4 divided by 4 plus 12, that is nothing but 16. So 4 VC of t divided by 4. But VC of t is nothing but minus 3 by 4 e raised to minus t by 8 into 1 by 4. It is nothing but minus 3 by 16 e raised to minus t by 8. That is P. So you got your complete answer here. This is how you have to solve answers, solve for a question. Did you get my point? Did you get my point, beta? Is it easy actually? At first time, no, if you doing this for first time, you may feel difficulty. When you do continuously the same problem but refreshing your mind again and again, then it will more and more familiar to you. And why this is very difficult to you means you are not at all familiar with the type of problem. That is why you might feel some difficulty, definitely. But if you try again and again over the same problem or the problems that we are going to deal with, definitely things will be easier. So don't worry and don't lose your hope, okay? Feel energetic all the time, okay? So let's do a next problem. Let's do next problem. Just do our problem, okay? Okay, let's write another question. Find VC of infinity. Find VC of infinity better. Find VC of infinity. Find VC of infinity. How can we solve such a question? Carefully observe the question better. Carefully observe the question. So, can you tell me whether it is an source free or sourceful circuit? How can we check that? At a t equal to 0, if the circuit contains a source, that is called the sourceful circuit. So it is a sourceful, right? It's a sourceful circuit. It is a sourceful circuit, first thing. And before that t is equal to 0 is considered to be, the steps are, I will follow the steps, you will definitely get the idea. First we have to do at a t equal to 0 minus, at a t equal to 0 minus. This means prior to the transience condition. What is the need of that prior condition we have to focus? Because this contain inductor as well as capacitor in some circuit. So in order to find the initial values of voltage in a capacitor or current in an inductor, that is why we have to do for such a prior condition, right? Prior condition. So before the t is equal to 0, the switch is open, right? The switch is open. That means this is not in the circuit, right? This is not in the circuit. Only this will be here, no? This will be here. And we know that t is equal to 0 means, 0 minus means it's a steady state condition. So under steady state condition or under steady state condition, capacitor C is open circuit and L, same manner, L is short circuit. This is very, very important. I will explain why. Under steady state condition means the capacitor is existing in the circuit for very long time. That means If the capacitor is charged from 0 to maximum, if you apply DC, 0 to maximum means at maximum point it cannot transfer any of the charge across it. That means it acts like a perfect impedance to the charges, because it's full of charges. It's full of charges. It can't carry or it can't accept more charges on its plate. That's why under steady state condition, steady state is nothing but a long operation condition, means this capacitor is on very long time before and it's continuously charging, and t is equal to 0 minus means steady state condition. No, prior to the disturbance occur, prior to the transient occur is considered to be the steady state condition. So at that condition the capacitor is considered to be open circuited because it's full of charge and it can't carry charge on its plate. It is full of. That is why it is called open circuit. The reverse is in the case of an inductor, because inductor is nothing but it store what? Energy in its magnetic field, right? Not in this static capacitic, electric field, it's in magnetic field. So inductor is considered to be at steady state condition. Initially, definitely at the time an interrupt occur, definitely what inductor will oppose it, because inductor has the nature of changing or opposing the rate of change of current in it, right? So when the switch on, the inductor definitely come into play and it will oppose the change, and when after some time the switch has opened, switch has switched on, what happened? The inductor slowly calm down, right? Slowly calm down, because there is no change in the conditions, there is no change in the current. So why I should act? The inductor thinks. So after some time of switching, t is equal to 0 condition, what happened? This inductor will be in idle position. That means it simply act like a resistor only. That means it simply short circuited. It will not feel angry towards the current, because the current is smoothly flowing, right? The current is not changing, right? Then the inductor thinks, why should I act now? Why should I act now? So I will keep quiet. That is why L is short circuited at t is equal to 0 or steady state condition. This is very, very important thing you have to note. Okay, so now when it apply here, what happened means at t is equal to 0 minus condition means the switch is not closed, right? The switch is open means this portion is not in the circuit. It is isolated, right? This is not in the circuit means it's not. The switch is open now. So the remaining portion will be what? I will write like this. 10 volt will be there, beta. 10 volt will be there. 2 ohm also will be there. And this will be open circuit. And there is a voltage exists in the capacitor is termed as the VC of 0 minus. That is nothing but the initial voltage. Because the fully charged, that charged voltage is represented by VC of 0 minus bus. The charged voltage represented by VC of 0 minus, not B. Is it clear? And because he is open circuited at a steady state condition bus. I already explained. So what is VC of 0 now? What is VC of 0 minus now? If there is any current flow in the circuit? No, because it's open now. So whole of the 10 volt will be available here, right? So VC of 0 is nothing but beta 10 volt. 10 volt. Is it clear? Is it clear? So VC of 0 is nothing but 10 volt. And we have to see another condition. Our aim is find VC of 0, right? VC of infinity, right? Okay, it's a sourceful circuit, right? So definitely we need VC of infinity also. Okay. Then what will be at t greater than 0? That means after the switching happened, what happens? What happened in the circuit? When the switch is closer to this position, the circuit will be in the form of what is that? after we switch on, I mean switch it to the on position, t is equal to 0, right? T is equal to greater than 0 mean after some time when it is switched on, this will be the nature, and this will be the nature of the circuit. This will be the picture of the circuit, right? This will be the picture of the circuit. And what happens, we have to find the what t is equal to okay. So listen carefully. At t equal to 0 plus, or simply t is equal to infinity. At t is equal to infinity means after long duration, after this t is equal to 0 happens, that's again a steady state operation, right? That's again a steady state condition, right? At t equal greater than 0 means it's simply what, after some time of this switching happens, that is t is greater than 0 generally. But t is equal to infinity means it's again come to its stable position after a long time. That is the meaning of t is equal to infinity. Then what will be the circuit diagram is, that means after long time interval also, what happened? The capacitor will be simply open circuited. The capacitor will be simply open circuited. And this will be Vc of infinity, correct? This will be Vc of infinity. This will be Vc of infinity, correct? At t is equal to infinity means the capacitor will be again open circuited, because it fully charged after a long time, so it will be again open circuited, and this voltage will be the Vc of infinity voltage, right? Then what is the value of Vc of infinity? Now we have to find this voltage, right? So this is a closed path now, this is a closed path now, so there should be some current I, there should become some current I. That current is nothing but beta 10 minus 2I minus 6I plus 5, sorry, this is minus and plus here, so plus 5 equal to 0. Correct or wrong? Correct or wrong, beta? Or I can write like 10 plus 1, it is 15 equal to 8I, or I will be equal to 15 by 8, correct? So I will be equal to what? 15 by 8. And what is this voltage? It is nothing but Vc of infinity. So I can write like this, 10 minus 2I minus Vc of infinity equal to 0. That means I applied a KVL to this loop. If you connect a voltmeter here, it will be a closed path, right? So I applied a KVL in this loop. I applied a KVL in this loop. So I can get like 10 minus 2I minus Vc of infinity equal to 0, because definitely there will be a flow of current, no? It is not open circuit, right? So Vc of infinity will be equal to 10 minus 2I, which is nothing but 10 minus 2 into, what is I here? 15 by 8, right? So it will be 10 minus 15 by 4, I will write here, or 40 minus 15 by 4, or simply what? 25, right? 4 volt. So that is the answer for Vc of infinity, 25 by 4. That is the answer for Vc of infinity. Is it clear? Is it clear? Is it clear? And if you asked for, my duster is skipping from my hand. If you asked for Vc of t, it's not asked in the question, but if you ask for Vc of t, then what will you write? Vc of t will be equal to Vc of 0 minus Vc of infinity into e raised to minus t by Rc plus Vc of infinity. Am I right? Am I right? So you have the value of Vc of 0 minus and Vc of infinity. And what is R here? What is R equivalent here? R equivalent is always I told you that R equivalent is considered to be always with respect to capacitor. You should write R equivalent if it is an RC circuit. Always consider with respect to inductor if it is an RL circuit. So it's an RC circuit now. So R equivalent I can write like, of course R equivalent is nothing but Thevenin equivalent, right? Thevenin equivalent, right? So no need to consider this voltage. If you are going to find resistor, no need to find this. Okay, so that is R equivalent. That means if you look from here, that means if there is a capacitor here, with respect to when I am the capacitor, I stand here. If I am looking to the resistor on both my sides, then what will be the effective resistance on my both ends? Here it is 2, here it is 6. So what will be the effective resistance? It is nothing but 6 parallel to 2. That is nothing but 3/2 ohm or simply 1.5 ohm. 1.5. So that is the R equivalent, and C is nothing but 1/3. So definitely Vc of t will be equal to beta what? Vc of 0. What was Vc of 0? What was Vc of 0? 10 volt, right? So it will be 10 minus Vc of infinity 25/4, right? 25/4, right? R into C, right? 1.5 into 1/3 RC plus Vc of infinity is nothing but 25/4. So this is the overall Vc of t. This is the overall Vc of t. If you asked for Vc of t also. If you asked for Vc of t also. What's the time now? What's the time now? Okay. Okay, I just checked my, no, it's focusing or not, I just checked. So that's all about the what, the question. Okay, okay, I will do the rest of the session on tomorrow. Okay, so that's all for today. That's all for today. That's all for today. We'll take tomorrow. So thank you so much. So keep studying. Okay. So good luck and have a sweet dreams. Good night. Okay. Bye.